Mr. Westwater here, about to take you through the 1HR, that's the first reserve paper from May 2022. So let's get to it. Right. So, question 1. Here is a biased spinner. It can land on either red, green, yellow or purple. Okay. So when the spinner is spun once, the probabilities that it will land on red or on yellow or on green are given in the table. Work out the probability that the spinner lands on red or yellow. Now, the first time I actually read this one, I skipped over this and I missed the red and thought, surely this can't be a question. And actually, marking a few of these, some people did miss the red part of this, but it's either red or yellow. We add those two together for 0.45. And on to part B. Yang is going to spin the spinner 300 times. Work out an estimate for the number of times the spinner will land on purple. So here we need to work out what the probability of purple is, and then multiply that by 300 to get an expected frequency. Okay, so one thing I do know is if I add all of these up, they will all sum to 1. So if I do 1 minus 0.25 minus 0.2 minus 0.2, then this is 0.65, leaving 0.35 left over. Okay, so purple must have a probability of 0.35, so if I do 300 times 0.35, that will give me 105. So my estimate for the number of times the spinner will land on purple is 105. Okay, on to question 2. In a warehouse, there are two types of shelves, type R and type S. These two types of shelves are arranged into shelving units that form the sequence of patterns. Here are the first few in that pattern, 2.4 and 3.5 here. So the width of each R shelf is 2.4 meters and each S shelf is 3.5. Work out the total width of a shelving that has 6 types of R shelves. So one of the key things that is worth noticing is that initially we have 2 to 1, then it's 3 to 2 in terms of R to S, and then it's 1, 2, 3, 4 R's to 3 S. So for every one new R1 I get one new S. So if I have 6 R types, that means I'm going to have 5 S-types. So I need to do 6 times the width of R, which is 2.4, and I need to do 5 times 3.5 the width of S. So 6 times 2.4, add 5 times 3.5, for a total of 31.9 meters. Okay. A shelving unit has n types of R shelves, and the total width of this shelving unit is W meters. So if we apply the same logic, if I have n R shelves, I'm going to have n minus 1 W shelves. I know ratios aren't really the things I should be using there, but they sort of highlight what's going on. So for each one of the R ones I have, remember we had to times by 2.4, and then we had to do n minus 1 times 3.5. So find an expression for W in terms of n. It's going to be n times 2.4, add 5, or not 5, sorry, n minus 1 times 3.5. But this asks for our answer to be in its simplest form. So let's think about this. This is 2.4n plus, now if I expand this, 3.5n minus 3.5, and I can collect these terms together for 5.9n minus 3.5. Okay, on to question 3. Here are 5 cards. The mean of these 5 cards is 12. Work out the value of x. Well, if the mean of these 5 numbers is 12, then the total is going to be 5 times 12. So the total of these cards should be 60. So let's add them up together and see what we've got. We've got 15, add 7 is 22, minus 2 is 20, add 23 is 43. So I know that 43 add x is 60, therefore x must equal 17. Okay, x is 17. And on to question 4. The language department of a college has 180 students. Each student studies exactly one of French, German, Italian or Spanish, and 15 students study French, 45% of the students study German. Express the percentage of students studying Italian or Spanish as a percentage of those studying French or German. So first we need to work out the number of people studying Italian or Spanish, and we need to work out the number of studying French or German. We're given the information about French and German up here, and as each student studies only one of these, I guess if there are 180 students in total, then the rest must study Italian or Spanish. So let's do this. So 45% of students study German. So if we do 180 times 0.45, that's 45% of 180. This is 81. Okay, so the total so this is German, okay, of French and German is going to be 81 plus that 15 for 96 in total, which means if there are 96 here, then Italian and Spanish must be the leftover, so that's 4 to get 100 and then another 80 to get 180, 84. So Italian or Spanish out of French and German is going to be 84 out of 96. So if I do 84 divided by 96, that's 0.875. It wants it as a percentage. Express the percentage of students. So this is going to be 87.5%. Go from a decimal to a percentage, we multiply by 100. Okay? And on to question 5. This is our first cluster question. Okay, lots of different questions involved. Expand. 3c cubed times c is going to be 3c to the 4. Okay, and then 3 times 4 is 12, so plus 12, and we've still got that c cubed as part of this other multiplication. Okay, then we have a factorised question. Now, we've got no common factors going on here. It's a quadratic, so we need to put it into 2 brackets. So we're looking for 2 things which multiply to minus 9. Well, straight away, as it's a monic, we can just put x and x in front, and because it's a negative, we know one bracket must be plus and one must be minus. And 2 things that multiply to 9 but then sum to 8, or have a difference of 8 if one's positive and negative, is going to be 9 and 1. Yeah, and if we want plus 8 afterwards, then we'll want the larger number to be positive and the smaller number to be negative. So plus 9 minus 1. If you think about expanding this, we'll get plus 9x minus 1x to get that plus 8x in the middle. And for B part 2, if this x plus 9 x minus 1 equals 0, then we can apply the zero product principle. In other words, if 2 things multiplied together equal 0, then either the first one equals 0 or the second one equals 0. So either x plus 9 equals 0 or x minus 1 equals 0, and therefore x equals minus 9 or x equals 1. Okay. Lovely. On to question 6. Okay, so here we have a show that question. Remember, whenever you see a show that question, take on board what you're trying to show, but then do not use it at any stage. Okay, hopefully we will reveal this at the end. So I'm going to start with just what's written on the left hand side. Okay, 2 2/3 plus 3 3/4. Okay, And the first thing I need to do is turn these into top-heavy fractions. So 2 times 3 is 6, add 2 is 8. So 8 over 3, add 12, add 3, 15 over 4. Now they need to have a common denominator before I can add them together. So they're both going to be over 12. Now this fraction I've multiplied top and bottom by 4 to get the 12 on the bottom. So 32 will be my numerator here. And if I've multiplied this 4 to get 12, I must have multiplied it by 3. So here we must have 45. And when we add fractions, we keep the denominators the same, add the numerators for 77. And lo and behold, this does equal 6 goes into 12, 12 goes into 77 6 times with a remainder of 5. So 6 and 5 twelfths. Okay, which is what we needed to show. Okay, and on to question 7. So, this diagram shows a solid cylinder made from iron. The cylinder has a diameter of 18 centimeters and a height of 3.5 centimeters. The mass of the cylinder is 7.04 kilograms. Work out the density of the iron. Give your answer in grams per centimeters cubed. Correct to 2 significant figures. Now, the first thing I've noticed is our units here do not necessarily match our units here. The centimeters is fine, but the kilograms is not. So the first thing I'm going to do is I'm just going to say that this is 7040 grams. Right, and now to work out density, I need the volume. That's why it's centimeters cubed. So how do I work out the volume of this cylinder? Well, it is actually at the front of the paper. You can think about a cylinder as just pi r squared h. It's also just the volume of a prism, so the area of the cross section times the length, so pi r squared times h. Okay, so let's get back to this question. So we're saying the volume is pi times r squared times h. So I know what h is, it's this 3.5. Now here 18 is not the radius though, this is the full diameter. So my radius is 9, and therefore my volume is going to be pi times 9 squared times 3.5. And all I'm going to do is I'm going to just chuck that into my calculator. So shift pi times 81 times 3.5, which is roughly equal to 890.6415 ... So I'm going to just keep that there as my answer, and then my density is going to equal my grams, so 7040 divided by, and that's what this, you can always use the units in these questions to help you out, the volume, so grams over volume, so the over 890.6415 ... So let's go to my calculator. 7040 divided by answer, and that is 7.90441 ... to 2 significant figures. Here's my first, here's my second. Draw the imaginary line. 0 would round this down, so this is just 7.9 grams per centimetre cubed to 2SF. On to question 8. Jane bought a new car for $18,000. The car depreciates in value by 15% each year. So before I read anything else, if it says depreciates, that means it goes down by 15%. If you start at 100%, take away 15%, you're down to 85%. Our percentage multiplier is 0.85. That's what I'm going to be using in this question. Work out the value of the car at the end of 4 years. So I guess after 1 year we would do 18,000 times 0.85, and then because it's compound and it depreciates by the same amount each year, we would take that result and we times it by 0.85 again. And then at the end of the second year, we do that again and again. But a better way of writing this is rather than times 0.85 times 0.85, you could just put squared. So if we're doing this 4 times, we could just say, I'm going to do this 4 times. I'm going to times by 0.85 to the power of 4. So 18800 times 0.85 to the power 4. And we get 9396.1125. This says give your answer correct to the nearest dollar, so this will be 9396. On to question 9. Solve the inequality. So we can treat inequalities much like we can treat equations. In fact, I'm going to give you 2 ways of doing this. So first, I'm going to subtract 3 from both sides, leaving minus 4x is less than or equal to 8. And then I'm going to divide by minus 4. Now the key thing is, when you're dividing or multiplying by a negative, you have to flip this inequality sign. Think about 1 being less than 2. If you divide this by minus 1, minus 2, the sign would have to swap around because minus 1 is greater than minus 2. So when we divide by minus 4, x has to now be greater than or equal to minus 2. Okay? If you weren't sure about that, what you could think about this as is if we start with 3 minus 4x is less than or equal to 11 again, I could instead add 4x to both sides. So 3 is less than or equal to 11 plus 4x, so now the 4x is positive. Take away 11, so we're at minus 8 is less than or equal to 4x. And divide by 4, which is a positive amount, so the sign wouldn't change. And here we get minus 2. So we've got x is greater than or equal to minus 2, the same that we got over here, just written the other way round. Doesn't matter which way round you write it, the answer is always x is greater than or equal to minus 2. On to question 10. The line L is drawn on the grid. Now, the first thing I'm looking at whenever we've got a grid already drawn is the scale. And it looks like each box represents 1 unit, so I don't need to worry too much about that from this point onwards. Find an equation for L. Give your answer in the form of y equals mx plus c. So m is my gradient, it's my rise over run. And so if I take 2 points, let's say this point here at 0, minus 1, and this point here at 2, 2, that has risen 1, 2, 3, and it's run along 2. Okay. Now my plus c is the y-intercept. Now this is passing through at minus 1, so c has to equal minus 1. So the equation of this line, I guess, is y equals 3 over 2x minus 1. Okay, m is 3 over 2, c is minus 1. But you could leave this as 1.5x as well if you wanted to. Okay. On to question 11. Now this was quite a big one. It was worth 6 marks and generally answered quite well. So let's see how we get on with it. The diagram shows a quadrilateral ABCD. In the diagram, ABC and DAC are right-angled triangles, with BC being 6 and AC being 7.5. The area of the whole thing is 31.5 centimeters squared. Work out the length of AD. So I guess the first thing I'm going to do is work out the area of this triangle ABC. I've got the base. Now I need to work out what the height is, and to do that I can use Pythagoras' theorem. So here is my hypotenuse. 7.5 is going to be my hypotenuse for this. So to work out AB, let's call it x. X squared plus 6 squared must equal 7.5 squared. So x squared plus 36 equals, what is 7.5 squared? 56.25. So take away 36 from both sides, and we have 20.25. And if I square root that, that seems nice, 4.5. Okay, so x is 4.5. So the area of ABC is going to be a half times the base, which is 6, times the height, 4.5. So that's just 3 times 4.5, which is 13.5 centimetres squared. Which means if we've got 31.5 centimetres squared overall, so if I do 31.5 minus that answer, then here we must have 18 centimetres squared. Let's just put that in. 31.5 minus 13.5 equals 18. Okay? So, a half times AD, let's call this y. So a half times y times the base, 7.5, must equal 18. So first let's times by 2 to get rid of this half. So 7.5y equals 36. And if I do 36 divided by 7.5, we get 4.8. Y equals 4.8. So that's going to be the length. Okay, on to question 12. And this looks like some properties of numbers with prime factor breakdown. So write down the highest common factor of P and Q. So this is where we're looking for things that they have in common. So they've both got 3's in common. In fact, if we were to write this out, P has 3 3's multiplied together, Q has 2 3's multiplied together. So they both have in common 2 3's multiplied together, so 3 squared. Essentially, you're looking for the lowest common power of things that are going on. So with the 5's, we've got a 5 over here and 5 squared. So this is just going to be a single 5. And same reason here, we'll just have a single 7. Okay. Now in part B, we're looking to work out the value of P cubed times Q. So P cubed, and it says give your answer in this index form as well. So P cubed is going to be 3 cubed times 5 squared times 7, that's P cubed, times 3 squared times 5 times 7 squared. Okay. Now when we've got a power outside, we multiply by the indices together. So 3 cubed becomes 3 to the 9, 5 squared becomes 5 to the 6, and 7 or 7 to the 1 becomes 7 cubed. And now we would add the powers together. So this gives us 3 to the power of 11, 5 to the 6 times 5, that's going to be 5 to the power of 7, and 7 cubed times 7 squared, 3 add 2 is 5, so times 7 to the power of 5. Okay, on to 13. Here is the number of runs scored by a baseball team in each of its 15 games this season. The number of runs has been arranged in order of size. So whenever we're working out the various things like this, and in this case we're looking for the interquartile range, we first need to work out the median. And if I've got 15 games, a quick way of working out the median is adding 1 to this and dividing by 2. So it would be 16 divided by 2, the 8th one in, so 1, 2, 3, 4, 5, 6, 7, 8. Here is my median. But if you weren't sure about that, you could just slowly work your way in. So that's 3 on one side, 3 on the other side, and then you've still got 1 left. So 7 is that dead in the middle number. Now, if you're looking for your interquartile range, that's going to be your upper quartile minus your lower quartile. And the upper quartile is basically the median of the numbers you've got above your median. Okay, so here we've got 7 numbers. Again, you can work your way in from the outside and be left with that 12. There's 3 on either side of that 12. So 12 is your upper quartile. And for the same reason, 3 down here is going to be your lower quartile. So your interquartile range is the difference between these two. 12 minus 3, 9. On to question 14. Simultaneous equations. So with these simultaneous equations, there's 2 ways you could go about it. You could either make the x's the same amount, or you could make the y's the same amount. I think I'm going to make the y's the same amount, just because. Okay, so let's make them have 15 y's in total. So the top one I need to multiply by 3. So that's 9x minus 15y equals 75. The bottom one I need to multiply by 4, so 16x plus, oh wait, yes, no, not by 4, by 5. I need to multiply it by 5 to get 15y. So 15y, 20x, and 70. Okay, now because the signs are different, we add these to leave 29x minus 15y, add 15y is 0, that's the whole point, and 145. So x, if I do 145 divided by 29, is 5. If x is 5, let's sub this into this bottom one. So 4 times 5, add 3y equals 14 to try and find y. So 20 add 3y equals 14. Take away 20 from both sides. 3y equals minus 6, and therefore y equals minus 2. We can check this in our first equation. So if x is 5, this is 15, minus 2 times 5 is minus 10, does equal 25. So I'm happy with that. 15 add 10 is 25. So x is 5, y is minus 2. On to question 15. Ooh, circle theorems. P, Q, R and S are points on the circle with centre O. PS is the diameter of the circle and angle PQR is 136 degrees. Work out the size of angle RPS. That is this angle here. Now one of the worst things you can do here is make assumptions. You can only use what's given. So I saw a few people labelling these as equal. At no stage can we assume that. Q could be anywhere along this sort of circumference of the circle. We can't make those assumptions, but what we do know is that our origin is here, and therefore if we think about this triangle, I know from my circle theorems that we have to have a right angle here, because the angle in a semicircle is 90 degrees. So I'm going to just write this out quickly. PRS is 90 degrees. Now, sometimes you have to give reasons. In this particular case you don't, because it doesn't say give a reason, but I'm going to anyway, and just for because it's a good habit. So the angle in a semicircle is 90 degrees. Okay, and I guess the other thing I need now to work out this one is this angle over here, ideally. So now I'm actually going to think about this as a quadrilateral. And I know that opposite angles in a cyclic quadrilateral, and this is cyclic because all the vertices touch the circumference, all of these must, the opposite ones must sum to 180. So if we've got 136 over here, then S has to equal 44 degrees, so that they sum to 180. So let's show this in working. RSP equals 180 minus 136, which is 44 degrees, and the reason for this is opposite angles in a cyclic quadrilateral sum to 180. Okay, Now, still haven't answered it because I need to work out what this is. So 90 add 44 is 136, leaving me with, oh sorry, no 134, leaving me with 46. So 180 minus 90 minus 44 equals 46. So this angle must be 46 degrees. Okay. On to question 16. Now this one again has two parts. Let's try and get through it as efficiently as possible. So three brackets. Again, always remember when expanding three brackets that just do two of them in isolation first. So you might want to start with these two and then multiply by this one. I've actually spotted something here. I've spotted that we've got the difference of two squares here. So you could notice this and multiply these together, knowing that this will just result in 9x squared minus 1, because those middle terms of plus 3x minus 3x will cancel out, and then it will make your next calculation, where you times it by the remaining x plus 2, even easier. So 9x squared times x is 9x cubed. 9x squared times 2 is plus 18x squared. Minus 1 times x is minus x. And minus 1 times 2 is minus 2. So there we are. 9x cubed plus 18x squared minus x minus 2. But you could have done this the long way round and ended up with a three-term thing first and then multiplied it all through. This was just the most efficient way of doing it. And part B, we are trying to simplify this fraction. So the first thing I notice is the power on the outside is negative. And when this is the case, the first thing I do is try and remember what a negative power does. It essentially flips the fraction. So if you have 3 to the minus 1, this is 1 over 3, because you can think about this as starting as 3 over 1, for example. So here we can think about this as 8xy squared over 2x to the 5, now just to the power of 2. Deal with that negative. Now I can bring this power of 2 in. So 8 becomes 64, x becomes x squared, y squared becomes y to the 4. Remember, we are multiplying these powers, and x is x to the 1. Then 2 squared is 4, x to the 5, 5 times 2 is 10, so x to the 10 here. And now I just need to cancel where I can. So 64 and 4 gives me 16 on the top. X squared and x to the 10 will leave x to the 8 below, so we have 16 y to the 4 over x to the power of 8. And some people left this as x to the minus 8 next to this, but either is absolutely fine as an answer. On to question 17. So, here is a parallelogram, PQRS, in which angle SPQ is acute. Okay, we're told PQ is 6.1 centimeters and PS is 3.8. The area inside is 18 centimeters squared. Work out the length of QS, which is this one here. Okay, and give your answer correct to 3 significant figures. Okay, so there's two ways you could go about this. We could go down the only use Pythagoras' theorem route, which was my initial thought with this, but you could use the trig formulae as well to work this out. I'll discuss that latter approach in a minute. I'm going to go down the pure Pythagoras point of view. Okay, so I'm going to use the fact that the area of this whole thing is 18 centimeters to work out what the height is, and then use Pythagoras' theorem with the 3.8 to work out what this length is, and then use Pythagoras' theorem with whatever's left over from the 6.1 and our height to work out the length of SQ. So let's start off by working out what the height is. Okay, so the area of a parallelogram is simply base times height. So 6.1 times h is going to be 18, and therefore h is 18 over 6.1. That doesn't feel like it goes nicely. I'll try it, but 6.1, no, it's just 180 over 61, just times the top and bottom by 10. As a decimal, it's this horrible thing that goes on forever, so I'm just going to leave it like that. I might even store it under A, just for future reference. Okay, now this whole bottom side is 6.1. I will need to work out what this is, so I can therefore work out what this length is. So if we've got 3.8 over here, I know, let's call this x, and this one y, then x squared plus h squared is going to equal 3.8 squared. So x squared will equal 3.8 squared minus h squared, this 180 over 61 squared, and therefore x will just be the square root of all of that. So let's just type that in straight away. The square root of 3.8 squared minus, and I stored this under a squared, and we've got 2.39 something. 4 dot 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 dot. Let's do 6.1. So y is going to equal 6.1 minus this 2.394 dot 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 dot. So 6.1 minus that, which is 3.7057 dot 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 dot. I'll store that under b, because that's the other thing I'm going to use in Pythagoras' theorem. We've got a here, b here, so to work out SQ, so SQ squared is going to equal 3.7 dot 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 squared plus our 180 over 61 squared. So SQ will be the square root of these two things. So the square root of b squared plus a squared, I think. Did I store that under a? Yes, I did. Which is 4.73. 7 dot 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 dot. What did it want it to? It wanted it to 3 significant figures, so this will round up to 4.74. Okay. As I mentioned, there are other ways. This was the first one that came to my mind, and it uses just Pythagoras' theorem. But if you wanted to, let's think about this over here. We could have split this in half and said I've got 9 centimeters squared here. And if this was 6.1 and 3.8, we could use the area formulae. So area equals a half AB sine C to work out this angle here, and then used this angle on these two sides to work out x using the cosine rule. That would probably be a bit more straightforward, but hey ho. Okay, on to question 18. The diagram shows the cube of length cube ABCDEFGH with sides of length 6 centimeters. T is the midpoint of AB and V is the midpoint of CH. So we've got 3 centimeters along here, we've got 3 centimeters along here, and we're being asked to work out the distance from T all the way down to V. So what I'm going to do is I'm going to break this into 2 right angle triangles. The first, which is actually going to be the latter one that we work out, is this right angle triangle here between T, this base, and V. And the second one is going to be between this point here, V, and C. Okay, so two right angle triangles. This yellow one is going to be my second one, and this green one will be the first one. So let's just put in all the measurements. So if I call this one, let's call this, I don't know, for lack of anything else, P. Then P, well, let's read it. Let's say this is going to be PVC. Okay, with lengths 3, 3 here. So PV using Pythagoras' theorem. So let's call this X. X squared will equal 3 squared plus 3 squared, which is 9 plus 9. It's 18. Okay, so X must be the square root of 18. Okay, root 18. I could simplify that. That's 3 root 2, but for the sake of this, I'm going to keep it as root 18, and you'll see why shortly. I'm now going to think about TPV. So here is T, P, and V. Okay, now I know this height is 6 because it's one on the sides of the cube. PV along the bottom is root 18, and we're asking to work out what, I guess, y is. So 6 squared plus root 18 squared must equal y squared. And now you can see why I've kept it as a square root, because the squaring and the square root will just cancel out and give 18. We have 36 here, and we have y squared. So y squared has to equal 54, and therefore y is going to be the square root of 54. Again, I could rationalise this, but it does say just give my answer in the form of root a, where a is an integer. So I'm just going to leave this now as root 54. Okay. On to question 19, and we've hit histograms. So remember, the key thing with histograms is the area represents frequency. So it says there are no trees below 200 or above 800. The number of trees where 300 between 3 the number of trees for which the height is between 3 and 400, so this amount here, which if we think about it is 6 of those 5 by 5 boxes, is 8 fewer than the number of trees between 400 and 500. So actually let's see how many of those big boxes we've got here. We've got, in fact I'll do this in a different colour so it's really clear. We've got 4 here, 5, 6, so that's the same area now, but how many extra do we have? We've got 1, 2, 3, and then I've got a half and a half of one there, so 4 big boxes equals 8, and therefore 1 big box equals 2. Okay, so work out an estimate for the number of trees in this part of the forest that have a height greater than 500. So let's see how many boxes we've got, and I'll use a different colour. Let's go green, be on theme for trees. We've got 1, 2, 3, 4, 5 for the 2 at the top, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. So if we've got 7 big boxes, that means I've got 14 trees. Okay, 14 trees. Again, there are other ways you could have done this. You could have worked out how much each tiny box represented. You could have had a go at working out what the frequency density of all of this was and done a scale on the left hand side. I've just gone for the most direct approach and said, well, area is frequency, and I've gone that route. Okay. Okay, on to question 20. And without reading it, it looks like we've got some similar shapes here. So, the volume is that, the diagram shows two similar metal statues. So the volume of statue B is 20% less than the volume of statue A. So we're talking about scale factors not just in one dimension. So before I get going, I'm going to write 1D scale factor, 2D scale factor, and 3D scale factor here. And remember, whatever your 1D one is, you square it to get your 2D, and you cube it to get your 3D one. So it says the volume of statue B is 20% less than the volume of statue A. So to get from A to B, we're timesing by 0.8. Okay, 3D scale factor is 0.8. The surface area of statue B is k% less. So what I need to do to this 0.8 is I need to cube root it. Cube root it to work out what the 1D scale factor is, and then I need to square it to work out what the 2D scale factor is. So let's put in the cube root of 0.8. I did that by just putting shift before the square root sign, and that gets me my cube root, and that's this horrible 0.92, 8 whatever it is. And now I'm going to square that, and this is 0.8617 ... So the surface area of B is k% less than the surface area of, thank you Jacob, of A. So what does this represent as a reduction? So this is 86.2% to 3 significant figures, which is what we're after, which represents 13.8% reduction. Okay. Does it want a percentage sign? No, it just says is k% less. So k equals 13.8 to 3SF. Okay. On to 21. Now we've got surds again. And as soon as there's a fraction involved with surds, I know we're going to have to rationalise this. Now, it says express 3 plus root 8 over root 2 minus 1 all squared in the form of p plus root q, where p and q are integers. Now, what you can do, because it says show each stage of your working clearly, this is because your calculator can just do it. So if you're curious where you need to go, you can type in something like 3 plus root 8 over brackets root 2 minus 1 squared, hit equals, and you know this is what you're trying to end up with. Although we need to tweak this slightly because q here is not a whole surd, but we'll approach that bridge when we get there. So first things first, I'm going to start, again, it's a show that, I'm going to start by saying 3 plus root 8 over root 2 minus 1 times root 2 minus 1. Double bracket it to show I understand what's going on. Now I don't know, I probably will need a bit more space, so I'm going to draw a line down the middle and see where we go from here. So 3 plus root 8 over root 2 times root 2 is 2, and then I've got minus 1 times root 2, so minus root 2, and I've got minus 1 times root 2 over here, so minus another root 2, and I've got minus 1 times minus 1 for a plus 1. So this is going to equal 3 plus root 8 over 2 plus 1 is 3, minus root 2 minus another root 2 is minus 2 root 2. Again, you could type this in on your calculator if you weren't 100% sure, and it would say 3 minus 2 root 2. Now, what we need to do here is rationalise. Now, when I'm rationalising, I need to look at what's on the denominator and think about not completing the square, sorry, the difference of two squares. So I'm going to times top and bottom, so 3 plus root 8 over 3 minus 2 root 2. I'm going to times top and bottom by 3 plus 2 root 2. 3 plus 2 root 2. Okay? Which is actually 3 plus root 8. but we'll cross that bridge when we get there. So let's put all of these things in brackets as we look to multiply them out. So on the top, we've got 3 times 3 for 9. I have 3 times 2 root 2 for 3 times 2 root 2 is 6 root 2. I'm going to actually think about this root 8 actually as 2 root 2, just so it's going to make life a bit easier when I multiply this. So I've got 2 root 2 times 3 over here, plus 6 root 2 again. And 2 root 2 times 2 root 2, well, let's think about this. 2 times 2 is 4. Root 2 times root 2 is 2. So this is going to be 4 times 2 for 8. Okay. And on the bottom, we have 3 times 3 for 9. We have, again, plus 6 root 2. But then we have a minus 6 root 2. That's the whole point. These two middle terms should cancel out. And then we have that same calculation, so it's going to make 8, but negative. Okay, so altogether, on the top, we have 9 plus 8 for 17, and we have 12 root 2. Okay, over 9 minus 8, so 1, and these two middle terms will cancel out. So this gives me 17 plus 12 root 2, because over 1 will just sort of vanish in a way, which is what we've got on the calculator. So that gives me confidence, but it's not what the question's asked for. The question has asked for it to be in the term of root q. So I need to adjust this surd so it's just one thing under the square root sign. I can do this by thinking about 12 as the square root of 144 times root 2, and these two combined are going to be 17 plus 2 root 2, 8. So 17 plus the square root of 288 is the answer. Okay. 4 more questions to go. Question 22. Now this one was not particularly well asked. There's a couple of things that give away what needs to happen in this question, which I will discuss now. So, the diagram shows the sketch of part of the curve with the equation y equals x squared minus p over x, where p is a positive constant. For all values of p, the curve has exactly one turning point, and this turning point is a minimum shown as the point t on the sketch. For the curve where the x-coordinate of t is minus 3, find the value of p. Okay, so this is when x equals minus 3. So, the key thing here is we're looking at turning points of curves. Okay, now if y equals x squared minus p over x, if I'm looking at turning points, this is telling me I need to differentiate. Okay, and set dy by dx equal to 0, because that will give me a turning point at that particular point. So the first thing I actually need to do is to rewrite this in the form that I can differentiate it. So y equals x squared. Now this we can think of as x squared in fact I'll write it below, minus p times 1 over x. Okay, which is y equals x squared minus p x to the minus 1. Okay, 1 over x is x to the minus 1. So now when I differentiate it, times by the power, take 1 away from the power, so 2x is the result of x squared, and then times by the power, so minus times minus 1 becomes plus 1, p, and then take 1 away from the power, to the minus 2. Okay, so we know at this turning point dy by dx equals 0, so we can now say 0 equals 2x plus, and I'm just going to interpret what this is, p over x squared. So let's take away p over x squared from both sides. We have minus p over x squared equals 2x. Okay, so minus p equals 2x cubed, and if x is minus 3 at this particular point, then minus p will equal 2 times minus 3 cubed. Minus 3 cubed is minus 27, so 2 times minus 27 is minus 54. So minus p equals minus 54, and therefore p is positive 54. Okay? The line with the equation y equals k is a tangent to the curve with the equation y equals x squared minus 16 over x. This is a very similar setup, but instead p is positive 16. Right? Now, when it says the line with the equation y equals k is a tangent, well, the line of y equals any number is always just this flat line. When this is a tangent, this is going to be a tangent again to a turning point. Okay? There are a couple of ways you can do this, but let's go back to our differentiation model where we have y equals, what was it, x squared, this time minus 16 x to the minus 1, and differentiating dy by dx equals x squared, 2x plus 16 x to the minus 2. So we're solving this equal to 0. So 0 equals 2x plus 16 over x squared. We can again add this to the other side, so minus 16 over x squared equals 2x. So minus 16 equals x cubed. And therefore, 2x cubed. And therefore minus 8 equals x cubed. And cube rooting that, x equals minus 2. But that's only telling us what the value of x is at this particular point. We need to know, so on our graph that would just be minus 2 here. We want the line of y equals something here, so we actually are interested in the minimum point, the y value. So I'm going to substitute in minus 2 into the original equation, y equals minus 2 squared, minus 16 over minus 2, which is going to be 4, and then 16 over 2 is 8, but we've got two negatives, so plus 8, which is 12. So k equals 12. Okay? Okay, on to question 23, and we are very near the end of the paper now. Express 2x squared minus 12x plus 3 in the form of a x plus b squared plus c, where a, b and c are integers. So we're looking to complete the square here. Now the first thing I need to do is remove the factor in front of x squared. So I'm going to rewrite this as 2 brackets x squared minus 6x plus 3. We can leave that 3 till the end. The key thing is taking 2 out of these two terms. Now I'm going to block out everything else and just focus on the x squared minus 6x and complete the square, which means I do half of this, so x minus 3 in brackets squared, and I take away the square of this term, so minus 9. Okay, that is me completing the square. Let's put it in square brackets for good measure, then add in the 2 and the plus 3 for good measure. Now expanding out this means I have 2 brackets x minus 3 squared, and 2 times minus 9 for minus 18. I still have the plus 3 left over, and neatening this up leaves us with 2x minus 3 squared minus 18 plus 3 is minus 15. So my answer is 2x minus 3 squared minus 15. Okay. Now, the curve with C has the equation 2x plus 4 squared minus 12x plus 4 plus 3. the point M is the minimum on C, find the coordinates of M. Now a lot of people went a very long route for this one and expanded all of this out and then had to go at differentiating and finding the minimum, and that would work, but it's very fiddly and very easy to make a mistake. What this question is actually looking for you to do is understand how to find the minimum from this form and then recognize that this equation is just the same as this equation that we started off with, but instead of x, we've got x plus 4, which is the graphical transformation of f of x plus 4. It has shifted everything to the left by 4. Okay, so what is the minimum originally of this starting equation? Well, if we start with x squared, that has a minimum at 0, 0. Then if I have 2x squared, well, this will actually still stay the same at 0, 0. So now if I change this so that it's 2x minus 3 squared, that is going to have shifted everything to the right by 3. It's this f of x minus 3 transformation. So let's say that this minimum is now at the coordinate 3, 0, but now it's minus 15. So then we've done f of x minus 15 afterwards because it's outside the brackets, so this is going to shift down 15. In fact, what I'm going to do is I'm just going to draw this further up and say that this is now at minus 15. Okay? Meaning that if I think that this is what I've started off at, I've then applied the transformation of x plus 4 to this, so it's shifted 4 to the left. This will now be at not 3, but minus 1. Okay? It will have moved 4 to the left, and our minimum will be at minus 1, minus 15. Okay? On to question 24, and one of the trickier questions in the paper. Elliot has X counters. Each counter has one red face and one green face. Elliot spreads all the counters out on the table and sees that the number of counters showing a red face is 5. Elliot then picks at random one of the counters and turns the counter over. He then picks at random a second counter and turns the counter over. The probability that there are still 5 red counters showing red faces is 19 over 32. Work out the value of x and show clear algebraic working. So the first thing I'm actually going to do is I'm going to show you sort of how my mind is playing this out. So I'm thinking about the tree diagram going on here. Now, when I turn the first one over, it could either be red or it could be green. And when I turn the second one over, it could either be red or it could be green. Okay? Now, the only way of ending up with 5 after starting with 5 is to flip over a red and then flip over a green to restore parity, or to flip over a green and then flip over a red. So these are our two probabilities, and I know if that the probability of that happening is 19 over 32, then the sum of that is going to equal 19 over 32. So it's all well and good saying this, but what are these probabilities? So initially we're told we've got x counters, and it says that there are 5 with a red face. So 5 out of x is our initial probability of it being red, which means how many green will we have if there are 5 red and x in total? It's going to be x minus 5 over x green. Follow that up. If I've taken one red and flipped it, that it will have now created an extra green counter. So if I started with x minus 5, I've now got one more than that, so that add 1 to this, this is going to be x minus 4 over x, following a red pickup. Similarly, if I flipped over a green one, I've gained a red one, so the probability of picking up a red one following that is going to be 1 more than the 5 I started off with. It's going to be 6 out of x. And all of this means that this 19 over 32 is going to be the result of this combination add this combination. So 5 over x times x minus 4 over x add x minus 5 over x times 6 over x will equal 19 over 32. Okay, how much space do I have? I've got enough space. So let's see what all of this is. So I'm going to multiply the tops together and multiply the bottoms together of each of these individual multiplications. Okay, so 5 times x is 5x. Let's do this a bit further up. 5x, 5 times 4 is 20. So 5x minus 20 over x times x squared. Add, and same sort of thing here, so 6x minus 30 over x squared will equal 19 over 32. I can now combine these fractions. Adding them together, they've got a common denominator. So 5x had 6x is 11x. Minus 20 minus 30 is minus 50. All over x squared equals 19 over 32. At this stage, I'm going to multiply through both sides by their denominators. So it doesn't look like it's going to be very nice, but we'll see what happens afterwards. So 19x squared will equal, what is 32 times 11? 352, there we go, 352x minus 50 times 32, 1600. Okay. Now, 19 being prime, I'm not 100% sure it is a factor of this, but I'm going to bring everything over to one side and say 0 equals 19x squared minus 352x plus 1600. And I'm not sure how this factorizes. In fact, I'm going to use the scapegoat a little bit, and I'm going to use the quadratic formula. So minus b, so plus 352, plus or minus the square root of b squared, so 352 squared. I know it's minus, but I avoid putting it in this formula because sometimes people put it outside and mess up the formula, so I'm just going to put 352 squared because it always ends up positive anyway. Minus 4ac, so minus 4 times 19 times 1600 all over 2 times 19, and hope that it gives us some nice solutions. So fraction 352, and we'll start with the plus. Square root 352 squared minus 4 times 19 times 1600 over 2 times 19 equals 10.52. 631 dot 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 dot, and if I turn this into a minus, or 8. So which of these makes sense? Well, what was x originally? Elliot has x counters. Well, I can't have a decimal amount of a counter, so I must have 8 counters. Okay, and we can check this if you want. No, actually I'm not going to, but yeah, if we had 8 counters, we can plug this in and say we have 5/8, and that becomes 4/8 for the green, because it would have started off as 3/8 and then 6/8, and you can multiply them together and we should get 19 over 32. Okay. Anyway, on to the final question, question 25. The sum of the first 10 terms of an arithmetic series is 4 times the sum of the first 5 terms of the same series, and the 8th term of this series is 45. So what we're going to have to do here, well, it says first find the first term of the series. So there are some formulae at the front of the booklet. I'm just, rather than go all the way back to the front, I'm just going to write them out. So the sum to n is n over 2 brackets 2a plus n minus 1 d. But there is also another formula which isn't at the front, and that's that an individual term let's call it un, is just a plus n minus 1d. Okay, and we're going to actually use both of these formulae in this question. I'm going to start off with the first statement. So the sum of the first 10 terms, so that's when n is 10. So 10 over 2, brackets 2a plus 10 minus 1, so 9d, equals 4 times the sum of the first 5 terms. So 4 times 5 over 2, brackets 2a plus n minus 1d, so 4d. So let's neaten this up and see what we've got. So 5, 2a plus 9d is going to equal 2 times 5, because these will cancel a little bit. So 10, 2a plus 4d. And we can expand this out. In fact, actually, no, I'm going to divide both sides through by 5 here. So 2a plus 9d equals 2, brackets 2a plus 4d. And expand this out, we have 4a plus 8d, 2a plus 9d, and so 2a equals d. That's all I can do for now, but now I can use this clue as well. So this is using my first sentence, so this is one useful thing that I've done. The 8th term of a series is 45, not the sum of the first 8 terms, just the 8th term. So I'm going to use my individual formula, which isn't given to you, but it's sort of a part of this formula, to work that out. So the 8th term, so U8, which is 45, so 45 equals a plus 8 minus 1, so 7d. Okay, now if d is 2a, I can now substitute this in to solve these simultaneous equations. So 45 equals a plus 7 times 2a. So this will equal a plus 14a. So 15a equals 45, and therefore a equals 3. And that's all this question was asking us for. Find the first term of this series. So a equals 3. Job done.